Hello everyone, we're the Tarmac team and our challenge was to reduce delivery delays. So the problem statement was about problem with productivity and that was due to delays in material delivery, and this was for building a road. The output was expected to be a dashboard including a map, and the benefits, obviously, in increase in productivity.
So our the first task that we wanted to do was obviously to produce this dashboard and hit that big chunky number of a 25% drop in productivity. Was look at the data that we had to work with. So we had three sort of main data sets. We had live truck movements, and that was a live feed. We had weather data, and we had observations on practices and the likes from the workforce. Once we started to dig into that, however, it was very clear that there were serious limitations on that data. So while we had, for example, live truck movements, which would be, you think very valuable, we didn't know where the trucks were going. Were they going away? Were they coming back? That sort of thing. The only status that we had on them, apart from longitude and latitude, was where they stopped, were they driving, were they idle. So there was a big limitation there. We also had weather data related to the site. We had lots of barometric pressure and the likes, but how useful is that to laying a pavement? The observations on the individuals that individuals made and recorded. I think this was a great example of where the human element comes in to the data. This was such a range of information. We had trucks that had spilt their loads being recorded, right down to a broken toilet seat. And we also know that Rambo is incredibly good at sweeping floors. So it really was really disparate information, and the actual impact on what we were trying to do and create in the dashboard was very limited. But we did have a go at making some recommendations and putting it together in the dashboard.
So this is the dashboard that we made. So on the left we've got a map. The four circles kind of show the different sections, and then the column charts next to each kind of give us a view of the number of trucks and their different sort of statuses, whether they're driving at their destination or if they're idle. The map on the top right is a truck location map. We've filtered it so it only takes the trucks that are idle, because we're probably not that interested in trucks that are at their destination or trucks that are moving fine. And then within that there's a sort of filter on the different reasons that we're given in the data for why they're idle. And then on the bottom right we've got a column chart of like the counts. So this was from the observation data, counts of the different incidents, and within those counts sort of split on reasons for them. And then, so looking at the data, we sort of had a sort of few recommendations on how we can improve sort of data collection. So with the observation data set, there were probably too many different categories for us to do a lot with, which made it kind of hard to do some analysis on that. And there were also sort of inconsistencies within the observations. So some things were recorded as good practices, whereas reading the descriptions, they were probably classed wrongly. And the other thing was the observations, they also had location data, but that data was recorded when the observation was recorded, which was, a lot of that was recorded back at an office. So we couldn't do any sort of analysis on where the observation occurred, because that location went back to an office. Also for the vehicle movements, we added a field sort of estimating, sort of guessing where each truck was, where their destination was, so we could do some sort of work with that, but that wasn't in the data, so that would potentially be something that could maybe be added that we could do some with. And then finally, just the weather data, perhaps didn't really need to be collected because of, I guess, so much open source weather data online that we can sort of easily pull in and use.
So what we'd like to do is to create some sort of dashboard that's with it, the data that's not too far away, that's actually realistic and can be used by the people that are controlling the sort of traffic. So we've got our map. Let's just drop a symbol of what the weather is on there, and only the weather that's impactful for the job at hand. We don't need to know that it's maybe 12 degrees or 14 degrees, but we maybe need to know if it's sunny or tipping with rain, if that impacts the practices. On the right hand side, let's have a look at the traffic that's just coming to site, and let's know what's going on. The other part of it that might be worth doing is actually keeping the data historically. Let's see if there's any choke points on the traffic that's coming in from all over the country, and to see if there's any learning we can do from that, not just the simple road closures here, there and another place. And then along the bottom there, we've just got the trucks that are coming to site, any that are idling. Again, we're focused on the idling being not good. It's the trucks want to go somewhere, but it's not doing that. And then just a big graphic on the right hand side there saying, a snapshot for the planners to see what's going on and what's bad, which is maybe where the focus needs to be. So it's not about churning out the masses amount of data. It's about the people who are actually going to do something or activate a plan, drawing the attention into the right area. But ultimately, pretty pictures and all the rest of it isn't what it's all about. There is a bottom line as well.
So we've had a stab at looking at potential productivity savings, looking at some numbers from Caterpillar, a manufacturer of asphalt pavers. They say that idling can represent as much as 50% of total vehicle run time. But let's say we have 30% idling time. That would represent 600 non-productive hours a year. And let's say we have 3 workers per pavement machine, so per section in the previous picture that you saw. And then there's some annual cost for the machine as well, and we assume 1 pavement machine per section. So the annual number for that would be about £180,000. Additional savings, of course, could be achieved by, so the material is delivered by contractors, and if you can improve the just-in-time delivery there, you would have additional savings in those contracts as well. Thank you.